And welcome back, and it's the higher plus 5 a day, and it is the 9th of March, and let's just go straight to the first question. Right, what do we have? So length and base of a triangle. Okay, so we're dealing with a triangle, and its perpendicular heights are. Okay, so on the one hand, this is just a basic what's the area of a triangle, but also it's a bit of algebraic fractions coming together. So let's start with the obvious thing. So the height of a triangle is a half the perpendicular height times the base. It just wants an expression, so really I'm just going to multiply a half by x plus 5 over 10 and multiply that by x minus 1 over 4. And I will say this isn't going to simplify nicely at all, is it? It's just going to be whatever it is. And that's going to be, on the numerator, it's going to be x plus 5, x minus 1. And the denominator, well, I'm doing 2 times 10 times 4, and that's going to give me 80 centimetres cubed. I don't think, 80 centimetres squared, sorry, it's an area, isn't it? Centimetres squared. I don't think I really need the units, but there we go. Now, it says expression, so I think if you wrote area equals, you'd be fine. But technically, this is an expression for the area. Anyway, first question done. Next question, and we have a vectors question. Excellent. Right, let's start with the important words at the top. So A, B, C is a trapezium. The definition of a trapezium is two parallel sides, or one set of parallel sides, I should say, that are joined by any two lines. So these could be a right angle or it could be different angles, but the point is I have one set of parallel sides. Now, having said all of that, it then goes and tells me that A, B, and DC are parallel, which means that this is some multiple of AB, which is 3B. It goes on then, that's probably why I should read the whole question first, goes on then to tell me that DC is two lots of AB, so DC equals two lots of AB, which is 2 times 3b, which is going to be equal to 6b. And I think for a question like this, you could have just written down 6b. It's probably only a mark. Then he wants BC. Now, this is why having the arrows is really important. You need to make sure if you're going against the arrows, it's the negative of what you see. All right, 6b here. So therefore, BC is going to be B to A plus A to D plus D to C. Now, if your teacher does minus DA, that's fine. It's the same thing. I just like to write the letters in the order I'm going in. It just makes it easy for me to remember what I'm doing. So B to A is minus 3B because I'm going against the arrow. Then I am going minus B minus minus A, which is plus A, and I'm adding on 6B. And then let's bring all that together. So I've got my A on its own. I've got minus 3 minus 4 plus 6, which is plus 2. So that's going to be A plus 2B. Yeah, happy with that? Yep, question done. Next question. Okay, solid sphere has a diameter of 12. So straight away, spheres involve radii. So the formula involves a radius, so therefore I'm going to write down, so I don't make a silly mistake, that R is 6, i.e. don't use a 12 accident. The sphere is made from glass. The density of the glass is 4.12 grams per centimetre. Just take account of the units. So these are in centimetres and I want my answer in grams. Find the mass of the glass sphere. Well, let's remember that density equals mass over volume, which means that mass equals density times volume. So actually it's just going to be putting it all together, isn't it? So therefore my mass is going to be 4.12 times, which is the density in grams per centimetres cubed, times the formula for the volume of a cylinder, which is 4/3 times by pi times by r cubed, which is 216, or 6 cubed. Get my calculator out, which I'm going to do right now. And that's going to give me 3727.688, etc., etc. Now, it doesn't say, and let the question guide you here, but I'm just going to say 3 sig fig, which is going to be 3730. And what am I measuring? I'm measuring mass of this glass cylinder. So that's in grams. So it's 3730 grams to 3 sig fig. And then it's question done. Nice question. Sort of nice question, bringing a few things together there. Final question today. Okay, what do we have? So y is inversely proportional to the cube of x. So we have a relationship between y and x. So in other words, y is proportional to 1 over x cubed, which means I can write that as y equals k over x cubed. Now, normally here it's find the k and then use a k, but actually this is quite a clever rewording. So what's happening now is I'm increasing x by 50%, and then I want to see what happens to my y. Now, the way I'm going to do that is like this. I'm going to say that y new is equal to k. What am I going to do? So k over, and x is 1.5, in other words, and multiplies 1.5, x all cubed. Then I get my calculator out, and so that's going to be k over, and 1.5 cubed is, it says 27 over 8, but 3.375. So that's 3.375 x cubed, which I can write as 1 over 3.375 times k over x cubed. And that's the same as 1 over 3.375. Well, this is just my original y, isn't it? And this is just quite a long-winded way of getting to the point that my new y is 1 over 3.375 times my old y. So the real question is, what is this number here? Well, again, if I get my calculator out and work that out, so it's 1 divided by 3.375, and that is 0.29629. That will do. Now that's a multiplier. So you remember a multiplier is after I've taken away the percentage or added the percentage. So in this case, because it's a reduction, my percentage change is going to be 1 minus this, which is going to be 1 minus that, which is 0.703. In other words, that's going to be 70.4%, and that is a decrease. Really nice question. That might be the first time you've seen a question like that. So do go through that again. Make sure you're okay with what I've done there. This sort of new and old method is quite a clever way of sort of working out what the changes might be. All I'm really doing, just to be clear, is I'm really just working out what is the value of 1 over 1.5 cubed, and I'm changing that to a percentage. That's all I'm really doing, but the setup allows me to compare before and afterwards. And that's it. Good mix of questions again today. Sort of nice, sort of, it didn't simplify as much as I probably wanted it to, but a nice sort of simple expression to start. Bit of an easy vectors question after some harder ones recently, and then a couple of nicer questions to finish us off. Let me know how you did. As ever, do leave some comments below. I like to read them. I will always respond to them. And of course, like and subscribe always helps the channel grow a little bit. Thanks all. Bye.